just start. All right, hello everyone, good morning, my name's Guy Davidson. Ah, there we are. Actually, if I can do that, I can say, my name's Guy Davidson. See, and you get the little thing on the screen. Anyway, I'm here to tell you what we mean when we say platform. So, yeah, Guy Davidson. I've been programming since 1980. Who here was born in 1980? Who here was alive in 1980? Okay, right. So I've been programming longer than most of you have been alive. Yeah, it just gets worse every year. I'm the head of engineering, not at Creative Assembly, but now at 6 Impossible Things Before Breakfast. This is a new venture that I'm part of. I was the head of engineering practice at Creative Assembly. They made me redundant at 10:30 in the morning on the day of my 56th birthday. Still, you know, they didn't get to choose that. So these numbers, BSI, IST 5, IST 5///21, I am a standardization person. So BSI is the British Standardization Institute, BSI IST 5 is the system, programming languages, system software and their programming interfaces and stuff like that. Because the UK is a monarchy, that makes me the king of programming. You may call me sir or your highness. IST/5//21 is the British Standard Institute's C++ panel, one of the programming languages, and I've been serving there for a while. ISO SC22, that is the international Geneva-based worldwide programming languages group, SC22/WG21, you might know as the C++ Standards Committee, on which I serve. I'm interested in linear algebra. I've been trying to get a ring buffer into the standard for a while. I would like to get geometry into the standard. Linear algebra is really important because at any one time, I think about 80% of any compute that's going on is linear algebra. And a disturbing amount of that is likely in Python. And that's going to be quite inefficient. And you may laugh, but it is actually serious. The amount of energy we consume performing linear algebra is shocking. And by making linear algebra that is efficient, readily available to the entire programming community, we can make a difference. So, just a thing, just saying. Right, platform. Here's a platform. What's that? Come on. What? It is a CPU. It is an Intel CPU, the Intel Core i7, as you can tell from the logo on the top. What's this? What was that? An operating system, particularly Windows. It's a platform, isn't it? It's a platform on which you do things. What about that? Yeah, it's another operating system. It's another platform, isn't it? What's that? That's a platform. That's the PlayStation platform. What's that? That's the Wi-Fi platform. You might call it a protocol, but some people call it a platform, and this is the problem. What's that? Yes! No, it's not. I love Visual Studio. I've been using it for a long time, a very, very long time. But it is a development platform. It really is. What's that? That is a railway platform. That is the longest platform in the world at Karnataka in India. Very long, apparently. Do you know what? I should have looked up how long it is, but I didn't. I leave that as an exercise for the viewer. Please contact it. Pardon? Karnataka in India. I don't know where it is either. I just said, what's the longest platform in the world? It said this one. I thought, great picture, stick it in the presentation, move on to the next slide. There we are. There's the next slide. Right. What do you mean by platform? Well, platform's a big business. Or at least they're big in business. Open any magazine or watch a random TED Talk and the chances are that you face the gospel of platforms. Even the esteemed Harvard Business Review focused on platforms in its April 2016 issue. Platforms are supposed to change the economics and the rules of the game in various industries. The advances of some wildly successful companies, such as Amazon and Apple, are often attributed to their platform business models. So, what's a platform? Is it a product family? In the early 1990s, when the word platform first entered mainstream business speech, are they organizational capabilities, or is it infrastructure, Or is it a collection of customer touch points? A market intermediary, a technology ecosystem? It's a very overused word. Let's look at some etymology, though. We need to look at the nature of abstraction first. So any of you who've been listening to me banging on over the past couple of years will know abstraction is a really important thing and something that I think everyone needs to be just a bit clearer about. I'm going to start with a little etymology. I asked a bunch of folk what they understood by the word abstraction. Oh, here we go. It's the lead, it's not the computer. Right, let's look at the nature of abstraction first. I'm going to start with a little etymology. I asked a bunch of folk what they understood by the word abstraction, and I got a big pile of rather varied and rather wrong answers. The Latin root of the word is trahere, which means to drag or pull, and it gives us words like tractor. It also gives us the word subtract, literally to pull under, but more meaningfully to take from, as well as retract, to pull back, for example, to retract a statement. We have contract, which is to drag or draw together, and extract, to draw out. Extract and retract may seem quite similar, and one of the confusions we have is the precise use of these prefixes. So when we come to abstract, which means to draw off from or draw away from, we might be grasping for a meaningful understanding of the word. And worse still, the word abstract can be a noun or an adjective, or a verb. Looking at nouns, an abstract can be a summary of a longer publication. It can be a theoretical way of looking at things, something that exists only in an idealized form. Used as an adjective, it can mean conceptual or ideal, and it can also mean difficult to understand. How apposite. Used as a verb, it means to summarize, or extract by means of distillation, or to produce an abstraction. And after writing this presentation, I was left with the notion that to abstract means to form a conceptual summary. Plectere, that means to fold, twist, or braid. Oh, you're moving, mate. I told you don't move. Okay, let's see how this works. Plectere, to fold, or twist, or braid. A simplex is a single fold triangle. A duplex, twofold. 2 floors in a building, 2 suites in an apartment. Duplex communication. Complex, manyfold. Or multiplex, comprising several interleaved parts. Now, complexity describes the idea of being unable to see the forest for the trees. Things are interleaved in ways which defy simple or simplex apprehension. However, the result of all the folding and complication is a new thing in itself. So, I hope you can see, there is a relationship between abstraction and complexity. Abstraction seeks to draw away the essence, while complexity seeks to create new things by weaving together old things. What does this have to do with programming? A valid question. Any C++ programmers here? Yay! All right, what's the API of a class? This is not a trick question. Now you're just telling me what the... Actually, that's interesting. You're just telling me what the... you're decomplexifying by spelling out what the acronym is. Oh, no! Do I need to stay still? Do I need to hover 6 centimeters off the ground? I can do that. I can just... There we are. Ah, this is the worst day in your life, isn't it, Elias? No, it's all right. Oh, good. There's going to be enough duct tape there to wrap up six bodies, I think. Great. Good job. Thank you. Yeah, the API is the private interface of a class. No, it's not. It's the public interface of a class. No, it's not. It's the protected interface of a class. Well, the API depends. If you're the person who's using the class, it's the public interface. If you're the person who's maintaining the class, it's all of the interface. I'm going to put public interface, though, because most of us are going to be using a class rather than maintaining it. That's an important point when it comes to writing classes. That's another talk. Any web programmers here? Okay, and what are you doing when you call an API?
Waiting for a response.
Yeah, you're asking a machine for a thing, aren't you? Yeah, absolutely. Just like in C++, you're asking a class to do a thing. You don't care how it's done, you just care that it's done. Great. Who knows about REST? REST? Yep, okay. There we are. Representational state transfer, that's lovely. All right, class. What are you doing when you write a class? You're abstracting. Or encapsulating. Ah, you haven't seen my other talk, have you? You haven't read my book, have you? No, you want to read my book, and I talk all about this at great length. Yeah, it's great. It's a good read. You should buy it now, actually. I can wait. You're abstracting when you write a class. You know, why make data private? Again, you're repeating the question. Why do you not want people to access your data? Ah, there we are. So they don't do something stupid with it. The reason why you have private data is to enforce class invariance, is to make sure that people can't... Oh. Hi. Oh. Sounds like unwrapping a Christmas present. Oh, Nintendo! That's a platform. Most Christmas presents are platforms. Platforms for purchase of other things associated with the Christmas present. Right. Okay. I can't see my slides there, but do you know what? It doesn't matter. I can see them here. Right. Why make data private? To enforce class invariance. I'll know. I have wide peripheral vision. Decades of Tai Chi. Right. Is a struct an abstraction? Yep. Yes, because the member identifiers are the API. So sometimes data can be an API rather than a function. Right, namespace, is that an abstraction? Yes? No. Because, well, kind of. It hosts an API, but all it does is prepend a name to it. You know, that's not really reducing any complexity. It's just, if anything, it's making it simpler by sticking a name in front of it. But does that really count as hiding complexity? What about a function? Is that an abstraction? Ooh, screen's back. It is. It's a single entry in an API. Okay? It's your classic abstraction. A function says, multiply by 2. And there we are. And then you have code that does the multiplying by 2. And you can probably work out what that code is doing. But the point is, you've got all right, find the 858th prime number or something like that. Find the nth prime number. I wrote a book about a lot of this. It turned into a book about abstraction. I didn't realize at the time. You see, this is what I get for focusing on the audience rather than just stepping back and looking at the black screen. I'm going to quote from the MVAR because it's not actually on the notes. So the last thing I wrote, the last page I wrote on this book, when I started to develop this book, I did not know what would be revealed to me along the way. Part of the fun of writing is discovering what it is that you don't quite know. In my day job, I frequently write short posts about how to use a language or library feature, and the process of clarifying it in writing forces a greater clarification in my mind. Now, writing 90,000 words rather than 1,000 has magnified this experience greatly. The one thing I will take away from this book is the primary importance of abstraction and of working at the correct level of abstraction. So many of the core guidelines, the core C++ guidelines, can be viewed as advisories in the... Oh, mate, congratulations. All right, I want you all to stand up and turn 90 degrees anti-clockwise. Maybe that'll work. Many of the core guidelines can be viewed as advisories in the service of improving abstraction. Now, messy code is more likely to hide bugs and harder to write. Okay? A good interface is easier and safer to use. Messy, low-level code breeds more such code. Okay? So, If you're not familiar with the core guidelines, they're numbered like this way. The P says, oh, it's part of philosophy, or C for constructors, or I for interfaces. Go and look up the core guidelines. Even if you never read my book, at least read the core guidelines. They're free, they're online. My book costs a bit of money. So P11, it encapsulates messy constructs rather than spreading through the code. So look at that. This is low level, and it's verbose, and it is error prone. And can anyone see what the bug is? No, you can't, can you? We forgot. Oh, sorry, I'm going to have to rush through this now because of the screen. We're not testing for memory exhaustion. Ah, hello. That bit where I'm saying p equals int pointer realloc p size of int. We're not checking for p being null, which is what it would be if we were exhausted for memory. The game, the function could fail there. Instead, we could use vector. That gets rid of all the bugs. Right. How many arguments opens opportunities for confusion? Passing lots of arguments is often costly compared to the alternatives. The two most common reasons why functions have too many parameters are, firstly, missing an abstraction. There is an abstraction missing, so that a compound value is being passed as individual elements instead of as a single object that enforces an invariant. And this not only expands the parameter list, but it leads to errors because the component values are no longer protected by an enforced invariant. That's a lot of words. The simple version is, don't pass loads of parameters, see if you can pass them as a struct, with rules, or as a class, with rules, with invariants. The second one is violating one function, one responsibility. The function is trying to do more than one job, and should probably be refactored. So if you've got a function, and you've got like a dozen parameters in there, actually, if you've got more than 5, frankly, you should be looking and thinking, nah, this is wrong. There's something else going on here. Ranges, for example. Ranges improve the standard library by replacing pairs of parameters, begin-end, with a single range. And it bundled the parameters into a higher level abstraction, into a range. Ranges are great. So a return value is self-documenting as an output-only value. Okay. Note that C++, it does have multiple return values by convention of using a tuple, possibly with tie or structured bindings. Anyone use structured bindings? Yeah, they're pretty groovy. Prefer using a named struct where there are semantics to the return value, otherwise a nameless tuple in generic code. Again, identify things, provide the abstraction, uncover it, expose it, rejoice when you find an abstraction. Readability, use class rather than struct if any member is non-public. Okay? Make it clear that something is being hidden or abstracted. Okay, it's a useful convention. If you've got invariants, put them behind a class, not a struct. Classes have private data to enforce invariants. That's the point. You can't muck anything up through the public interface because you've got your invariants being enforced. Prefer using the standard library to other libraries and to handcrafted code. Code using a library can be much easier to write than code working directly with language features. It's much shorter, it tends to be of a higher level of abstraction, and the library code is presumably already tested, particularly the standard library. The C++ standard library is among the most widely known and best tested libraries in the world. It's available as part of all C++ implementations. Go and use it. Large parts of the standard library rely on dynamic allocation. So these parts, notably the containers, obviously, they're not suitable for some hard real-time and embedded applications. But most of the time, the standard library and the containers are going to be what you want to use. Don't rewrite the standard library. If a container isn't quite appropriate, write one that is, and give it a different name. Don't just say, oh, I'm going to do a vector, but it behaves like this. Don't do that. Don't reuse the name and change the meaning. People will hate you for a long time. Prefer suitable abstractions to direct use of language features. So a suitable abstraction, for example, a library or a class, is closer to the application concepts than the bare language, so it leads to shorter and cleaner code, and is likely to be better tested. Right, okay. It's easy to see what this does. Yeah? The more traditional and lower level near equivalent is longer, messier, and harder to get right, and most likely slower. Looks like this. Oh. When I see code like that, my heart sinks. Okay, let's carry on. You know, once the checking for overflow and error handling has been added, that code gets quite messy, and there is the problem of remembering to delete the return pointer and the C-style strings that array contains. And this is one of the classic pieces of early teaching you perform when you teach C++ to people who are used to programming in C, a lower level language. Don't use malloc and free. Don't use initialization and deinitialization calls. It's error prone. You find yourself making calls before init, and that's, you know, it's no good at all. Your synchronization can get messed up. And really, don't use new and delete except in the most exceptional of circumstances. You know, when you're developing a new data structure, for example. You know, the bookkeeping is error prone. Use make unique, use make shared, or better still, don't use make shared. It's global mutating state in disguise. It's horrible. Please don't use shared pointer. If you want to contain lots of objects, use a container like std vector or one more suited to the problem at hand. Now, we are running really quite short on time. So this is the OSI, the Open Systems Interconnect platform, which describes how networking works. And the idea is that each layer, oh yes. All right, man. Thanks for your efforts. I do appreciate this. I really do. The idea is that each layer provides the platform for the next layer. You know, the physical layer, that's about wiggling electrons around. And then this is not great for my flow or for your comprehension, I'm sure. So the data link layer sits on top of the physical layer. So the data link layer relies on the stuff that's exposed by the physical layer. The data link layer doesn't need to know how the electrons are oscillated. It just needs to know that there's something there that it should rely on, and so on, all the way up the stack. Like that. I've got lots of text here to describe the fine, subtle nuances of platform, but not here. You may have heard of the phrase full stack developer. It comes from working across the OSI model. People who say, yes, I'm comfortable at all levels of the OSI. But yeah, they are mythical beasts. They don't really exist. During this conversation, somebody said, oh, do you know what, I tape out my own microprocessors. And I said, great, how's your CSS? You know, the stack is full, deep. Hi. Oh, this is the UI platform for a car. Think of the complexity of a typical car, all right? All you need to know is condensed into a bunch of pixels. Okay, how fast you're going, you know, how fast the engine's going, what you're listening to. I've never listened to Booty Man. This is the best picture I could find. I had to make a call as to what the music would be, and I decided no. They all know that I never listen to Booty. I've no idea who Booty Man is, frankly. Right, now I never thought I'd see one of these. This is the UI platform for a coffee machine. Now, when did making coffee get so complicated? Really, I'm not a coffee drinker myself. I didn't quite realise how sophisticated these could be. They could be amazing. The coffee machine we had at Creative Assembly was this. It was like HAL from 2001. Just big giant thing. Anyway, right. What does cross-platform programming mean? Okay, so we're going to look at some chip architectures. Anyone? Nope. Great. Anyone here know how to program an x86-64 processor? Yeah, a little bit. The people with the beards, and yeah, the people with the age behind them. AMD, Intel. Any ARM programmers here? Yeah, ARM's good. Yeah, I like ARM. Right, so I started programming on Acorn computers. They made the first computer that I wrote code on, the Acorn Atom, and they became ARM. Acorn RISC machines, and then advanced RISC machines, and then ARM holdings. ARM don't actually make processors anymore. They license designs of various degrees of abstraction to manufacturers, like Apple who make this laptop and my phone, and other device manufacturers who make other phones. There's a great line from their Wikipedia entry. Intel competed with ARM-based chips in mobile, but ARM no longer has any competition in that space. ARM has no competition in their space. However, vendors of actual ARM-based chips compete within that space. So ARM are making the shovels, and everybody else is digging the gold. Anyone heard of RISC-V? RISC-V is worth researching. It's an open standard instruction set architecture, started in Berkeley, 2010. RISC-V International is currently headquartered in Zurich. And I do recommend doing a bit of research. This is the next architecture you're going to be working with. ARM may soon have competition in their space. What do they have in common? Well, they're all instruction set architectures. They're abstractions over silicon switches. Any C++ programmers here? Yeah. If you go to Compiler Explorer, then you know that you can build the same code for different processors and it will do the same thing. Cross-platform programming means writing code that works on multiple architectures. No, it doesn't. Let's look at the three main compilers. GCC is the oldest. It used to be a C compiler, and then it was a C++ compiler around Christmas 1987. I happen to know it was Christmas 1987 because at that time I was just starting ads in C++, and suddenly GCC does it. Yeah! I didn't have to use C-front anymore. Any regular GCC users here? Good, cool. How about MSVC? Yeah, come on. That's the Microsoft's Visual Studio Code, yeah. Anyone know when that came out? February 1993. Again, I remember it well because it shipped with almost a meter of documentation. Who remembers measuring documentation in metric? So a meter of documentation. I had a 1 meter bookshelf, and all the everything on that bookshelf was documentation for Visual Studio, including documentation for C++ and documentation for the Microsoft Foundation classes. That was the big one. That was this big. Because there was no such thing as online documentation back then. What did we do before we had online documentation? We suffered. That's what we did. If nothing else, the World Wide Web has saved a gigaton of trees. It's only that much. And I imagine more of you... So how many MSVC users here? Okay, fewer than I thought. Clang. Everyone loves Clang because it provides a compiler front end that works in tandem with LLVM. And it was first released a couple of days before my 20th birthday in September 2007. No, it wasn't my 20th birthday. Any guesses? It was my 40th birthday. Any Clang users here? Yeah. Right, what do they have in common? Well, they turn C++ into the desired instruction set architecture instructions. Are they platforms? Yes, they are. Each implements C++, but in very slightly different ways, with different interpretations of the standard. Different choices about implementation define behavior. Right now, I'm helping develop a code base for 5 OSs using these 3 compilers. My first job is to eliminate all warnings from the code base shared across the 3 compilers. And I can assure you what flies through one compiler without comment can cause quite a lot of trouble for another. And I did a talk about this at the ACCU conference in 2015. I'm not sure if it was recorded, I don't recall. So what do we mean when we say platform? It's a problematic word. It seems to have many definitions. It gets used in a lot of places. It's become ambiguous. Remember the train platform? It's the thing you stand on to get onto a train. Rather than having to use steps, it supports your body weight and your intentions. And I'm going to say that when we say platform, we mean a named set of abstractions which provides a specific set of services. And this is vague, and it's not very useful. So whenever you hear the word platform being used, you should ask yourself the question, what is your abstraction context here? Because if nothing else, it will cause the person using the word to make sure that they know what they mean. So my call to action, though, is to stop using the word platform entirely. It's been overused to the point of uselessness. Be clear in your speech and say what you mean. Thank you very much. Do I have time for questions? Does anyone have any questions? Brilliant. I've stunned you into submission with my wall of talk. Fire hosing text at everyone. Seriously, none at all? Oh, go on. Go on, go on, go on.
So you talk about a lot about abstraction in really low level, and at this level we still do abstraction, but you talk about interface and struct and class and just access that we let. Do you think you can do too much abstraction? Is it a problem to do too much abstraction and don't let
yes, you can. So you used the word level there, which I didn't really touch on extensively because that's where it all really, that was what the OSI diagram was about. I was describing levels of abstraction. I don't know why I'm waving over there because I know that's a picture of me. But there were levels of abstraction. And this is the thing, when you're creating an abstraction, your problem domain becomes your solution domain. And it becomes the domain for the next problem that you're solving. You know, you build some tools, and then you build some more tools that use those tools, and then you build some more tools that use those tools. That's how your abstraction layering takes place. What you can do, of course, is you can make your abstraction really tiny. And so you and when the abstraction is too tiny, you've used too much abstraction. That's often what people mean when they say over-engineering. But it's up to you to decide what is too much abstraction. You know, that is the art of programming. The art of programming is working out how much complexity to hide behind how little information. That's the art. You know, there is no science, there's no magic to it, and that's why programming will always be hard and will never be mechanized and automated by AI or things like that, because it's up to you, the designer of the problem, sorry, the designer of the solution, the understander of the problem, to work out what is the optimum abstraction here.
Thank you.
All right. Excellent. It just takes one, you see, and then they'll flood out.
So to follow up on this point, because you were mentioning that you loved the day when you didn't need to continue using C and do things that C++ standard to make the, let's say, more abstractions and help you abstract more. Yet you're not the JavaScript or Python programmer. So where do you specifically, personally say where is the level that you want to stick to, and where do you want to be in this, let's say, stack of abstraction?
All right, good question. Well, to be honest, I program in C++ because the things that interest me, that have always interested me, is driving hardware. And when GCC started supporting C++, it didn't mean that I could stop using C, because I went kind of straight from assembly to C++. I didn't really have much time in C at all. And I was using C-front, which is what Björn Stråstrup wrote in the first place. So originally, he wrote C-front, it converted C++ into C, and then C would compile. And this was a great idea, because it meant that he could use all the C ecosystem that was in place, the linkers, the debuggers, all of that kind of thing. And actually, Herb Sutter is doing the same thing now. He's, designing C++2, and he's doing it by transpiling, which is an awful word, transpiling C++2 into regular C++. And so you can write beautiful, clean, lovely code in C++2, and you can still benefit from the entire C++ ecosystem. I don't really have much interest in solving the problems that JavaScript and Python are used to solve. Those problems don't really interest me. Having said that, I've got a server in Belgium, or is it Luxembourg? I've got a server somewhere in Northwest Europe, and the website has lain idle for a long time. And actually, maybe I just need to get the hang of web programming so that I can start doing that kind of thing. And maybe I'll learn those things. But I love twiggling, I love hitting the processor and getting that to do things optimally. I'm like a petrol head, who likes driving really, really fast cars. That's what I am with system hardware.
Thank you.
All right. Thanks very much.